Hey everybody, today's section 4.5, solving equations. So hey, just as a heads up, this is a tough section. I'm going to kind of skip around and do some of the examples on tonight's video and the rest of the examples on tomorrow's video. I have already worked out a warm-up question here, stuff that you already know how to do. And you will also need your calculator for today's lesson so that you can be typing stuff with me, making sure you understand how to type things into your calculator. So graphing calc is preferred. Scientific calcs can also do logs, but it's easier on a graphing calc. So if you need to pause the video, get yourself organized, copy down this first warm-up. That would be fine. I'm going to breeze through this warm-up really quick. Again, this is something that we have already done. And the purpose of these is to rewrite with the same base. This is a 3. This you can write as 3 cubed. Once you do that, your exponents are equal to each other. And so then you just do this, distribute your 3, combine your like terms, and you end up with x equals 1. So really quick review problem. But what we're going to do today is actually figure out how to solve them if you can't rewrite with the same base. Very first problem I'm going to do is number 1. And what you'll notice here for all these examples that I do is I have like steps over here to the right. And each problem is kind of different. And that's one of the reasons why this section is pretty difficult. But I want you to write the notes down, get everything copied into your packet, and then tomorrow in class what we're going to do is go over all these problems hardcore, do some practice, do Math Excel, and figure everything else out, okay? So very first problem, solve for x. Our steps over here are to get the exponential term, which is this term, by itself. So easy thing to do first would be just to minus 3, so we'll do that. Step 2 is to take the natural log of both sides. I'll talk about that in a second. And remember that exponents come down in front when you do logs. So let's go right into example number 1. Very first thing I'm going to do, like I pointed out originally, is to get this 3 away. You guys probably already were thinking about that. That means 2 to the x equals 6. And so here's the problem. What we used to do is we would rewrite both of these as the same base, but you can't write 6 as 2 to some power. There's no way to do that. And so here's the crazy part, is that in order to bring that exponent down in front and solve for it, I need to take the natural log of both sides. And remember, whatever you do to one side, you have to do to the other. And the whole purpose of doing that is that now this exponent can come down in front. So what I have now is x ln 2 equals ln 6. The trick here to solving these is taking the log of both sides. You know how for other equations we will square both sides or add 1 to both sides or, I don't know, square root both sides, things like that. In this case, we're logging both sides, natural logging both sides. Now to get x by itself, just keep in mind that this is a decimal in your calculator. This is also a decimal in your calculator. So to get x by itself, I just have to divide both sides by ln 2. That's what cancels this. And I have x equals ln 6 over ln 2. And so here's where you need your calculator, is that on like homework and stuff, sometimes it'll ask for an exact answer, which this would be your exact answer. I'll write that, meaning no decimals. But keep in mind that if you're going to use the calculator, it might say like round to 2 decimal places, round to 3 decimal places, whatever. So you're actually typing into the calc ln. Remember, it opens up a parenthesis when you do that, divided by ln 2. Be careful with closing the parentheses. And that gives you a decimal approximation of 2.585. So this is your approximated answer. Okay? So there's 2 different ways that I'm going to ask you to write your answer. In exact form, which means don't use the calculator, or in approximated form, which means yes, actually type it into the calculator. Just as a side note, if your scientific calculator, I don't know, some that we'll talk about in class tomorrow, but you could also just do regular log of both of these. And if you also type, I'm going to actually write that just so you guys know, could also type log 6 divided by log 2. You still get 2.585. Okay, so log button or ln button, either way is fine. I just use the ln button because selfishly it's a little bit less writing. It's one less letter that I have to write. So it's easier to write ln than it is to write log. But you could use either button in your calculator. It will give you the same decimal. Okay, just keep that in mind. Number 2. Next one I'm going to write. So there's no way to rewrite both of these with the same base. Yeah, I know that 8 is 2 to the third, but there's a 3 on this side, and that would make a 2 on this side. There's no way to rewrite these. So what we are going to do right away is ln both sides. When I do that, the whole purpose of doing that is that now I can bring both of those exponents in front. So here's what I have, and it's going to look a little bit crazy. I'm going to keep this exponent in parentheses, and this is x ln 8. So I know it's confusing, but just keep in mind that this is a decimal. It's like, I don't know, point something. This is also a decimal. So don't be freaked out by all these ln 3s and ln 8s. I'm just writing it as that instead of using a decimal right away, because writing all those decimals throughout the whole problem would really suck. So what I'm going to do now is distribute this decimal into this parentheses, which is a little strange. I have x ln 3 plus 5 ln 3, and on the right hand side I still have x ln 8. Now what you'll notice is I'm trying to get x by itself. That's what the question is telling me to do, and I have an x here and I have an x here. That means you need to get your x's together on one side and get everything else on the other side. So what I'm going to do is move this entire term over to this side so that it can join the x. So this side is going to stay 5 ln 3. That's just a decimal in your calculator. I'm just continuing to write 5 ln 3 equals x ln 8 minus x ln 3. All I did is I moved this term over to this side. Now you can probably see what comes next. You're going to factor out the x. ln 8 minus ln 3. Those are not like terms. You cannot combine that into ln 5. I just keep that in mind. You can't combine those, but on this side I have 5 ln 3. So now just in order to get x by itself, I'm just going to divide both sides by this quantity. ln 8 minus ln 3. Divide this by ln 8 minus ln 3. This all cancels away, and this is what I have for x. This is my exact answer. Okay, and I will be asking for that. And now the hard part is typing this whole thing into the calculator. Yes, in your graphing calculator you can type it all at once, but you just have to be careful because remember that the calculator will open up a parenthesis every time you hit a log button. So you're going to have a bunch of parentheses when you type this into the calculator. So pause the video, go ahead, try and type it exactly the way you see it. Yes, you need these parentheses in the denominator because that tells the calculator everything that's in the denominator. And when you type that in, you should get 5.600 as your approximated answer for x. Okay, so it's kind of a little bit strange with all those ln's everywhere. It's something totally new and different that we haven't really talked about before. But that is how to do example number 2. And just keep in mind that instead of using the ln button, I could have used just the regular log button, and that would have still given me the exact same answer for x. Okay, next problem I want to look at together. I'm going to skip, actually I'm going to go right to example number 3. This one is very, very similar from the one we just did. I encourage you to pause the video and see if you can try and do it on your own, and then just check your answer with the video. But in order to do this one, I have a 4 on one side and a 5 on the other. I cannot rewrite those using the same base. So what I have to do is natural log both sides. And when I do that, the exponents come down in front. You can only do that if you natural log both sides. So I have 3x ln 4 equals this quantity x minus 2 ln 5. Just like we did the last one, distribute that left-hand side. You get x ln 5 minus 2 ln 5. And this side is still 3x ln 4. Okay, so from here what I'm going to do is I'm going to bring this term over to this side to group my x's together, and this term over to this side to get that constant term on its own. So it's going to become positive 2 ln 5 when this moves over here. And then on the other side, I'm going to have x ln 5 and then subtract the 3x ln 5. Again, now you want to take out the x. That gives you ln 5 minus 3 ln 5. And this side 2 ln 5. It's really tempting to cancel all those ln 5s. You cannot do that. It doesn't work that way. But what we're going to do now is just divide by this entire quantity on both sides. Ln 5 minus 3 ln 5. That's what cancels this and this. This is your exact answer. And go ahead and try and type this into the calculator to get a decimal approximation. Remember, be careful with those parentheses because it'll open up a parenthesis every time you hit the log button. So this answer, x should be equal to negative 1.263. Go ahead and try typing that. Verify that you can type it. You can use the log button or the ln button, doesn't matter. But make sure if you have a question or an issue on that, that you bring it to class tomorrow. Let's go right to example 5. This one's a little bit easier. What we're going to do here is, thankfully, we have e's everywhere. So we're able to write the same base on each side. But first thing we're going to want to do is combine these. Remember when you have the same base and you're multiplying with exponents, that means that you can keep the base and actually add the exponents together, because we need to have an e on each side. So this becomes e to the 6x equals e to the 12. And now that there is an e on each side, that means that your exponents are equal. So this is kind of a review problem. We get x equals 2, no calculator needed, but the key thing here is to combine them first so that you have one e on the left and one e on the right. Because it's tempting to want to cancel all of these e's right away, but you can't do that. You can only do it if you have one on each side, so just keep that part in mind. Let's take that same kind of thought process to this example, number 6. I just have a couple more I want to get through. You guys are doing great. I know it's a hard section. First thing that I'm going to do is add the 5 to both sides. Hopefully that's one of the things that you were thinking about doing originally. This is 4e to the 2x plus 3, and on this side I get 16. And again, I can get rid of this 4. I'm going to divide both sides by 4 just to cancel that. So I'm left with e to the 2x plus 3 equals 4. And now here we are again, kind of in those problems that we did at the beginning. The goal would be to write both of these with the same base so that I can set exponents equal. Yeah, you can change 4 to 2 squared, but that wouldn't make it match the e. So the goal here again, we are going to ln both sides. That is what allows the exponent to come down in front. Guys, the entire purpose of having logs is to be able to solve an equation where the x is in the exponent. That's the whole reason they were invented, for lack of a better word. Okay, so again, this exponent is a quantity, so I'm putting it in parentheses. Here's something awesome about this problem. Do you know what ln e is? Isn't that just log base e of e, which isn't that just 1? So what's awesome about that is that anytime you have ln e, it's kind of that smiley face cancellation rule, or you could think about it in terms of what's the exponent on e that gives you e. This all goes away. This is 1. So what's awesome is that I have 2x plus 3 equals ln 4. Now I just have to solve for x. So I'm just going to leave my answer as exact as possible. I'm going to start by subtracting 3. So this is ln 4 minus 3 equals 2x. And then divide both sides by 2. Divide by 2. This is my exact answer. And then when I go to the calculator, just check that you can calculate this in your calculator as well, the approximate answer. Be careful with the parentheses here. Close it after the 4. You should get an answer of negative 0.807 as the approximated answer. Okay, so cool thing about this problem is that since we natural logged both sides, ln e cancels. But still we end up with a decimal answer because ln 4 is not a whole number. Okay, there's only one more problem that I want to go to, you guys, and we're going to skip all the way to number 10. And then that'll be a good spot to pause, and we will finish up the rest of these in the next video. But example 10 is the next one. Keep in mind for all these problems I have kind of like hints and tips and stuff to be thinking about. So always condense equations first. You guys just had a quiz over expanding and condensing, so that's interesting. And also don't forget how to rewrite stuff. So we're going to look at that as well. Okay, so for example number 10, what I want to think about first is that I'm pretty sure that I know how to combine two logs if they're being added together. That was kind of what we just had a quiz over. I think you can make it one log. And by the way, it's just a base 10. There's no number there with it, so just remember that it's a 10. And what I'm going to do is combine the x and the x squared, and then just keep the right-hand side the same. All I did is I combined the two logs together by using the multiplication property. So this turns into log x to the third equals 3. This is weird. And then when you're stuck, you guys remember the trick is always to rewrite. Remember my little symbol I like to use when I do that translation? And so remember this is a base 10, so if I'm going to rewrite it using BAE, I'm going to go 10 to the third equals x to the third. Well, snap, just by rewriting it, this seems like a way easier equation. This means that 10 equals x. Okay, so that was kind of a little bit of a review-like problem, but always keep in mind stuff that, like, don't forget the easy stuff we learned about logs. You guys have already learned how to combine, so do that. Also, you have learned how to do that translation. Doing that translation is one of the best tips that I can give you. If you're ever stuck, translate it, and it becomes a much easier problem. Okay, I know that was a lot, you guys. You did an awesome job. Come with questions to class tomorrow. There will be another video to finish this page of notes tomorrow, but we're going to pause and do some practice and just make sure we're cool on these examples tomorrow. So bring your questions. Thanks for watching. Have a great night.